Okay, welcome back to algebra. Today we're going to be solving more linear equations. This time the focus is going to be with fractional statements. So in particular, if we look here, this is an example of a linear equation that's set up in a fraction form. And so this is sort of like, I would say, the most difficult way to view a linear equation problem. And so I wanted to walk you through that. All right. So again, I've said this before, but there's many ways of sort of thinking about how to solve for x here. And I think one of the most memorable ways, and the one I'll use today, is something called cross multiplying. So cross multiply. So what that means is you're going to take the numerator here on the left, and you're going to multiply it by the denominator over here. Okay. And likewise, you're going to make a cross, and you're going to use the denominator here on the left and multiply it by the numerator on the right here, x. And so what you end up with, right? So let me look at this first. The 3 over here and the 2x minus 1. What is that? Well, it's just 3 times 2x minus 1, okay? And that's going to be equal to what's on the right side, which is just 4 times x, or 4x. And now we can see here that we don't have any fractions anymore, which is a good thing. And from here, you can sort of see what you need to do, right? On the left side, I want to sort of get rid of this 3 on the outside, and I'm going to do so by distributing, right? 3 times 2x and then 3 times negative 1. Well, 3 times 2x is going to give me 6x. And then I have 3 times negative 1, which is negative 3. And of course, this equals to 4x. All right, now I'm going to get x by itself. I have x on both sides. I just want to get one. I want to get all the x's to the other side. Doesn't matter which side you choose, to be honest. I'm going to subtract 4x over here and 4x over here. 4x minus 4x is equal to 0. So we have 6x minus 4x minus 3 is equal to 0. Okay, now I have 6x minus 4x, which is just, I have 6 x's and I want to take away 4 of them. I'm left with 2 x's. And then I have this minus 3, and I just want to get that to the other side by adding 3 as well. So this 2x is going to equal to 3. All right, last step is to divide by 2 on both sides, like so. Because if you have something in the numerator that's the same in the denominator, they cancel out. And of course, I'm left with x, which is my solution, 3 over 2. All right. So here's another linear equation with fractions involved. This one can be solved in different ways. Some ways are a little more difficult than others. In this case, I will show you the easier method. I want to point out here that we have a lot of even numbers, which is like a great way to sort of simplify things, right? When you have even numbers, you know that you have multiples of 2. As you can see here, I have a 2 here, I have an 8 here, and a 4 here. And so what I want you to think is, okay, since they're all, if I look at the denominator here, this denominator is the largest one, right? 8 is the biggest number out of these. So I'm going to use that and just multiply everything by 8, right? The reason why I do that is because, right, if I multiply this by 8 and I multiply this by 8, then I have 8 divided by 2, and that's going to leave me with 4 in the numerator. And then here, if I have 8 divided by 8, that's actually just going to give me 1. And here I can just multiply by 8 as well. So it simplifies things really nicely. And so let me write that all out. So again, so we have, so I'm going to multiply 8. I'm going to multiply everything by 8 just so I can cancel out the denominators everywhere. All right. So in order to do that, you literally multiply this whole equation by 8. So I'm just going to distribute it here and here. And then I'm also going to have to multiply by 8 over here as well. All right. So I have 8 times x plus 2 over 2 plus 8 times x plus 4 over 8. And that's going to equal to 8 times 4. All right. So again, I have 8 over 2. 8 divided by 2 is just 4. And I'm going to leave that x plus 2 for now. No more denominator. It's just 1. On the second term, 8 divided by 8 is just 1. So I'm left with what's in the numerator, x plus 4. And that's going to equal to 8 times 4 is 32. All right. Last but not least, I have this 4 here that I need to distribute out. Well, I have 4x plus 8, and that's going to equal to, 4x plus 8 plus x plus 4. Notice I dropped the parentheses here. It's totally fine to do that. It's just a property of associativity. You're allowed to do this in math. It's fine. Unless you have a multiple greater than 1 outside, like we did with the 4 here. And that's why I distributed early, so I can drop all the parentheses. Okay. So now I'm going to group terms together. I have a 4x here and I have an x here. And then I have an 8 here and a 4 here. So I'm just going to group those terms together. 4x plus x. I have 4 x's over there on the left, and I have 1 x on the right. In total, I have 5 x's. I have 8 and I have a 4. 8 plus 4 is just 12. And of course, that equals 32 still. I'm going to subtract 12. Again, I want to get x by itself. So subtract 12 on both sides. These cancel out. I'm left with 5x on the left. And on the right side, I have 32 minus 12, which is 20. Okay, last step is to get x by itself. I'm going to divide by 5 on both sides. 5's cancel out. On the left, I'm left with x. And then 20 divided by 5 is going to give me 4.